Hi there, welcome to The White Side of the Brain, a podcast dedicated to exploring the world of white matter. I'm your host, Anna Casal, and in each episode, we dive deep into the science behind the 60% to 80% of the human brain that plays a crucial role in its function, development, and aging. At BrainTale, we are pioneers in the measure, quantification, and normalization of white matter. We offer cutting-edge software solutions and medical devices that are transforming brain care through precise and objective data. Our mission is to bring together scientists of excellence, pharmaceutical professionals, and healthcare providers to advance brain health through impactful innovation. Join us as we discuss the latest technological and scientific advancements in the brain disease treatments and explore how these innovations are improving patient care. Brain diseases are one of the most urgent medical challenges of our times. By understanding more, we can treat faster together. Welcome to the very first episode of The White Side of the Brain. We're going to uncover the integral world of white matter and its impact on brain care. Today, we are privileged to have Professor Louis Puybasset with us. Professor Puybasset leads the ICU at la Pitié-Salpêtrière Hospital in Paris, and he collaborates with teams at the Brain and Spine Institute called ICM. His research and clinical work focus on the complexities of coma and the pivotal role of white matter in such critical conditions. Join us as we explore the profound connections between white matter injuries, the brain, and consciousness, and learn why this knowledge is essential for both the medical community but also the public. So thank you for being here, Professor Puybasset. Let's go back to your background and specialization. So can you share your journey and what led you to specialize in the study of coma and white matter?
It's a long story, it's more due to my career. In fact, I began in the ICU more than 30 years ago, but I first worked on lung disease, acute lung disease, acute respiratory distress syndrome in the ICU. And at that time, I developed software based on CT scan to measure the lung weight and the lung density in these patients. And so I did a lot of papers with this technique, and then I had to move for local reason. I had to move to be the head of a neuro ICU.
Here at la Pitié-Salpêtrière?
Yes, here. Okay. And in fact, there were two neuro ICUs. There are two departments, and I had to merge together these two neuro ICUs. And they had an attitude toward the end of life that were totally opposed. And in one of the ICU, they really wanted not to lose any chance for all patients. So they over-treated a lot of patients, and somehow they created a lot of vegetative patients and minimally conscious patients. And in the other ICU, were very against producing somehow these patients, so that they stopped care very quickly. So it was like North Europe and South Europe inside the same building. And the only way to merge these two attitudes, these two teams, was to develop a real tool to know the prognosis, based on the patient itself and not cultural ideas.
So something scientific and something very tangible.
Yes, and so I tried to reproduce the quantitative radiology I did on the lung, somehow to the brain. First I worked with CT, then quickly with MRI, and I really tried to get figures, numbers out of the MRI of the white matter. And very quickly I observed, the patient per patient, that the white matter assessment through DTI was very much correlated to the outcome. So since 20 years now, I work on this subject because I think it's really fundamental to treat the patients.
So is it a passion for you? What excites you the most in this specialty?
Well, in this specialty, it's very mysterious, because you don't see anything of the body. It's all inside the brain, and it's really something about the soul. Where is the soul?
So there's something spiritual mixed with the scientific approach for the
Yes,
public.
because if you do not recover consciousness, if you stay vegetative, in fact, who are you according to who you were before? And this status of vegetative patients, they do exist only because of medicine. That's the point. these patients do not exist without medicine. It's like the extreme of ICU care. And it's the only way, if you overtreat the patients, you somehow, you not create these patients, but you make them survive wishes, And in all the other ICUs, that does not exist. If you overtreat the patient, at the end, you just lose some days of ICU, but at the end it's the same, but not in no ICU. In no ICU, if you do not enough, it's a disaster for the patients. But sometimes if you do too much, it can also be a disaster for family. You need to really balance your treatment, and since you don't see anything on the patient, then you have to go somehow inside his brain and to try to understand the prognosis according to the lesions.
Okay, great, very clear.
Just to better answer to your question, in this medicine, the quality of what you're doing has a tremendous importance on the outcome of the patient. The impact is enormous, especially because these are very young patients, so they will live with the consequences of their disease combined with your treatments for decades. So what is at stake is very high. You see, and it interrogates the fundamental sense of ICU.
Yeah, that's
why
a huge
would
challenge.
You do that? Yes.
Yeah, completely. Now let's focus on white matter. How do you define white matter? What is white matter clearly, and why does white matter matter?
Well, white matter is about, let's say, 70% of the weight of the brain, of the volume. White matter is made of the axons. A neuron, you have a body, a cellular body, and you have axons. These axons can be very long. They are finished by synapses to connect to other cellular bodies of neurons. So this white matter, it's made of billions of connections. It's the substrate for connections between billions of neurons, of cellular bodies, of the cortex, but also of the basal ganglia nuclei. Because in the brain, you have basal ganglia nuclei, especially the thalamus, and you have a cortex. And the white matter is the billions of connections between all these cellular bodies that produce the information. White matter is the way to transfer the information from one part of the brain to the other part. It's the connection system within the brain.
Okay, very clear. And why does white matter matter? Is it very crucial? The role of white matter has been underestimated maybe before?
White matter is the basis for connections between neurons. So it's fundamental. If you have no white matter, you have no connection, you cannot create anything. Even though you might have some cortexes, some pieces of cortexes that works well, if they're not connected to other pieces, it's worthless.
Yeah.
So white matter is essential to the integration of information within the brain. You have no white matter, there is no connection. There's no integration. If there's no integration, there's no consciousness, and there is no thinking, and there's nothing.
Very interesting, yeah. I would like to ask you the connections between white matter and the consciousness, but I think you explained it quite well.
Just to precise, being conscious is related to a type of conversation within your brain. A conversation between the different cortexes, frontal cortex, parietal, occipital, temporal, whatever. All the cortexes, they need to speak together with the basal ganglia. So it's a huge conversation that produce the idea of being yourself and your thinking. This conversation is really basically physically connected to the connections, to the white matter. So somehow there is a link between the quality of this network, the white matter, and the quality of your consciousness. And to a certain level, if it is too much destroyed, you will not make it. It will not recover because you will not be able to have these communications, very high-speed communications between the different cortexes. And the fact is that in all this coma of structural origin, the common denominator is the alteration of white matter. That's the point. White matter is the common denominator of the destruction after cardiac arrest, TBI, subarachnoid hemorrhage, intracanal hematoma, and hypoglycemia, for example. This is the 5 diseases we try to prognosticate with DTI. This is very different from coma due to substances, intoxications, sedation, medication, CO intoxication, inflammation, infection, and so on. So In order to have a relationship between coma outcome and white matter, you need to have a structural destruction of white matter, which is basically the structural coma, I would say.
Okay.
Coma because of structural alterations, not functional alterations.
So how long have you been working in this field?
Oh, a long
For
time.
years? Decades?
20 years.
20 years.
Yes,
So.
20 years. Next year it will be 20 years.
So you've witnessed a lot of technological advancements and innovation. How these advancements and innovation change your understanding of coma and white matter?
Well, basically, it's not that much things, it's basically DTI. What changed everything is the appearance of this diffusion tensor imaging possibility within clinical machines that we use on the daily basis with patients. So that is true that it appeared about 2005. Then it improved as a quality of image, but the concept is the same since 20 years. The issue is the normalization of a signal, meaning that every machine will give different numbers according to the settings of a machine and the machine itself, and the software that is inside and the antenna. So what we did since years and years is the harmonization, meaning that we compare patients to a group of controls of normalized patients, let's say, to be able to compare these different machines and the DTI acquired within different machines.
Looking ahead, how will white matter in 10 years from now, according to you?
Well, since white matter is the basis for communication within the brain, I think we will concentrate more and more on this structural anatomy and network for this intra-brain communication. I think that we will work a lot on aging, because with aging you have progressive lesions of white matter. Also, after a trauma for years and years, you can have inflammation within the brain that will continue to deteriorate your white matter. After any brain insult, we will work more on inflammation, chronic inflammation of the brain that has very long-term consequences on white matter. And what we can hope, well, the hope is to get treatment for white matter regeneration. Because as of today, there's nothing to repair white matter. Unless you have inflammation, you can change inflammation, but if you have a destroyed white matter, as of today, you cannot change it. So what we are looking for is treatment that will somehow recover
or regenerate,
improve the quality.
Okay.
It will never regenerate. It is generated during embryology.
Okay.
These connections, they are built up when you are in the belly of your mother. During the first months of life, you have these connections. But let's say to improve the myelin and the capacity of the myelin and the integrity, or avoid a further deterioration. Maybe not improve it, but avoid a continuous progressive deterioration of white matter.
Okay. So now let's speak about discoveries. Could you share with us how you originated the clinical need and technological perspective that has become a reality with BrainTale? Because as a reminder, you are one of the, let's say, creator of BrainTale.
Well, BrainTale, the point is that we developed software very close to BrainTale for years and years within Pitié-Salpêtrière, and we had a small network in France. So we were using these tools, but it was not CE marked. So it was it was cumbersome to use that in medicine first, and secondly, it was impossible for us as academic people to have a huge development of this technique worldwide. So when we decided to build up BrainTale, it was really to get the capacity to provide quantification of white matter everywhere. For every patient, and not only Pitié-Salpêtrière patient or a small group of French patients. So that was really the idea, dissemination. The idea of this company was to build up a tool allowing us to disseminate the use of DTI. That's a long story of BrainTale. Because of a clinical need, there is a profound clinical need in coma patients, yes, because it's tremendously important to know where you're going with the patient and to inform families, to have a discussion of continued or not care based on science and not on thoughts or culture. So that is tremendously important for patients. But it's not only coma patients. Finally, it's all the neurological field is involved, in fact, in white matter lesions. And if you do not measure an organ, there's no way you can improve it. So, for example, for liver, for the kidney, for the heart, we're measuring these organs since decades and decades and decades. And really the quantitative nature of the organ is really the first basis for any treatment. If you do not quantify things, there's no way that you will treat anything.
Yeah.
So you need to quantify first. That's the tool, the basic tool to study any medication, any therapy that could change the organ itself. But if you have not the tool, there is no way that you can study this organ, at least trying to improve it. So what we're expecting from BrainTale is provide biomarkers as for the kidney or the liver, let's say, echography of the heart. It's something that is standardized because we need standardization. It needs to be the same figures all over the world that the medical community, the industry, the pharmaceutical community has something to rely on to prove that therapy is efficient or not.
Okay, that's kind of new language, or the same language for everyone to speak.
It's like it's the same thing that we did for other organs.
Okay.
There is no difference with, for example, cardiac ecography. Cardiac ecography, they had years and years to get normalization, standardization, even of the names of the sequences. And then we were quantifying things within the heart. And that was the basis to see if treatments were working or not, the basic for surgical decision, the basis for all the decisions according to the heart are based on echography and standardization of echography. For example, for the liver, it's been like decades and decades that we measure the liver enzymes and the liver biomarkers, and that all decisions are based on these biomarkers. So it's exactly the same routine analysis for the brain, but the first insight with quantitative measure that you can change with time, or change with therapy, is based on DTI. Clinically speaking, I mean something that can be used in every patient everywhere.
Okay, very clear. Could you share with us some of your most significant findings concerning white matter and coma?
Major finding is that there is a relationship between the status of the white matter and the coma outcome. Somehow, it's not like a linear thing, but you can, using DTI, you can separate, disentangle for the same clinical status, those patients that will not recover consciousness because they are below the threshold, the lower threshold necessary to have this conversation within the brain, from those patients that will certainly recover. But in between, you have a gray zone, a non-response zone, because you cannot assume everything. So the tool we're developing gives an answer for about 70% of the patients. And if you're in the gray zone, but you have to repeat the exam. If there's other ways, you can also repeat things. So the major finding is this relationship, but you need to determine the threshold. That's the point, because there's a clear relationship, but the finding is to determine, according to the age and the delay of MRI, the threshold for determination of poor outcome and good outcome.
Okay.
It's a threshold issue. It's a statistical stuff.
And why do you think it's crucial for the public and healthcare professionals to have a better understanding of white matter?
Well, if we consider that white matter is involved of nearly all the neurological disease, it's crucial that people know what we speak about and that this become a routine measure. Maybe in 10 years, all the MRIs will get a quantitative approach to white matter so that you can follow your brain as you follow your kidney, or as you follow your liver, as you follow your heart, In your life, you will get maybe 100 measures of your kidney function. Because as soon as you get a blood test, you have kidney function for any reason, surgery or whatever, any disease. So in a life, you get 100 measures of kidney function. And for liver, it's pretty the same. For the heart, it's less, but you have a lot of specific exam for the heart that you will get in your life. But you get nothing for your brain, which is very strange, because your brain is really the main organ you need. So in the future, very likely you will get not continuous measure, but regular measure of your white matter. And with this notion of normal aging, you will have to follow a normal curve for your aging. If you divert from this curve, you need to be very aggressive on the risk factors for your brain.
Very clear. What will be the impact on patients if they knew how to analyze better white matter?
Well, if become, let's say, familiar with this notion of white matter, and they will take attention, they will pay attention to their brain. And the brain status, brain health is really the challenge of the century.
Yes.
Because what is the interest of being treated of vascular disease, of cancer, of diabetes and whatever if you have very poor brain at the end, So aging is fine if you keep your brain. So this notion of brain health, at least in the Occidental world, will, I think, be more and more important with aging. So you have this notion of what is a good aging and what is a bad aging for your brain. But to know that, the only way is to measure it and to follow it.
Yeah. Okay.
And if the patient get familiar to that, then there will be this interaction with the physicians to get this proper brain aging.
And you can be treated faster?
At least you can treat it, maybe not, but you can reduce risk factors as of today. Maybe tomorrow we get treatments. And if you have beginning of the white matter disease, you'll be treated that way or the other way. If you have a neurological disease, you have many neurological diseases, then it's fundamental to know the status of this disease and to try to stop it the quicker as possible. But to know that, you need to go inside the brain. And you not only images, not morphological images as of today, you need to get numbers, because numbers get statistics, follow numbers. Yeah. If you get only images, it's not possible to get statistics on images.
Okay.
That's a major difference.
Okay, is there a final thought or message you would like to leave to the listeners of the episode and about the importance of research on white matter?
Well, if we want to summarize, I would say that first, brain health is the challenge of the 21st century.
Yeah.
Secondly, that the first step to everything is to get reliable measures of the brain integrity, of the white matter integrity. And third, that DTI is key for this purpose, because it's the sequence that is getting everywhere. Every MRI today can provide these numbers according to specific normalization and treatment of a signal as provided by BrainTale, for example.
Okay. Who would you recommend we invite here in the podcast?
There is a very well-known and fantastic physician at the hospital, Pitié-Salpêtrière, called Fanny Moschel. And this lady, she's a specialist in ALD, adrenoleukodystrophy. She's a disease of white matter, but where you have some treatment. The only disease as of today, when you have a treatment that can change white matter integrity, that we can measure with DTI. Okay. With the first data on DTI and ALD. And this is a type of paradigm, in fact, of a disease, a treatment, a white matter integrity, and numbers that you can change according to the clinical status, very linked to clinical status.
So thank you very much, Professor Puybasset. We're going to call Fanny Moschel to invite her. And thank you for sharing your expertise with us. Thank you.
Welcome.
Thank you so much for listening to The White Side of the Brain. We hope today's episode shed light on the critical role of white matter in brain care and the innovations transforming care. Stay tuned for more discussions with leading experts as we continue to explore, learn, and work towards better treatments together. Until next time, let's keep pushing the boundaries of brain science.